In this video, we're going to start talking about coordinate geometry. Why we look at coordinate geometry is because coordinate geometry allows us to take numbers and letters and put them on a graph so we can have a picture and have a common language to talk about them. Coordinate geometry allows us to solve problems of intersections. So where straight lines, quadratics, circles, those kind of things intersect. So I want you to think about where some situations might be that you want to do that in the real world. At the end of this unit, what you'll be able to do is you should be able to find the equation of a straight line, interpret and use the different forms of a straight line in solving problems, understand the relationship between the graph and its equation, understand the equation of a circle and be able to find its center and its radius. And then using algebra and the methods we've been looking at up to this point, solving equations of intersections with circles. So to start with, we're going to talk about line segments and midpoints. So recall that a line segment is a line that has a beginning and end. So it usually has a dot at the beginning and a dot at the end. And usually it's denoted with an overbar, AB, or something similar like that. So we can define it using coordinates or vectors. So vectors denote change in state, meaning they have a magnitude and direction. Best to think of it as a right triangle. So if we think we have this vector here, it has A and B. We have no idea where this point is, where it starts, but we know the change in X and Y. So looking at vector notation, so we've got AB, 2, 4, and 4, negative 2. So remember we looked at vector translation being X or Y. So let's think about, we'll call this the V vector. What is the change in X? Well, that's 2. The change in Y is negative 6. So that is our vector. So if we bring back our vector of 2, negative 6, once we have vector form, we can use the distance formula. This is the distance formula. This is the Greek letter delta, meaning change. So this is saying the change in X. So sometimes we denote that as x2 minus x1. So we've already done that because we have the vector. So we know that 2 squared plus negative 6 squared, square root. So 4 plus 36. What do we get? The square root of 40, which is going to be 2 square root of 10. So this is the length of our line AB. Next, we have the midpoint formula. We've talked about this a little already. Remember, midpoint formula, define a line into 2 congruent, meaning 2 equal halves, and it's an average. So you take your 2 coordinates, you add them up, you divide them by 2. So that's your midpoint formula. The midpoint formula and the distance formula are not given to you on your formula sheet, so they're going to be things that you're going to want to memorize. The other thing we look at a lot is what we're used to calling slope, but what Cambridge will refer to as the gradient. Remember, your slope or gradient equation is rise over run or y over x. There's your slope formula. Again, that's not given to you. Hopefully, you already have that memorized. If not, that's something you're going to want to remember. Generally speaking, we denote slope as m, but remember, Cambridge likes to switch up the variables, so don't 100% rely on that. Recall that two lines are parallel if their gradients are equal. Okay, so if their slopes m1 and m2 are equal, then they are parallel, so long as they're not collinear, meaning so long as they're not the same line. Two lines that are the same line can't be parallel. Let me draw that out because that might be confusing. This line and this line both have an m of 2. They are parallel. But this line and this line are collinear. They have the same slope, but they cannot be parallel because they are the same line. They're equal to each other. So that's parallel. And if you're sketching by hand, remember we denote parallel with some symbol on the line on both lines. Perpendicular. You're going to get a lot of find the perpendicular bisector of line segment AB or equations like or problems like that in the Cambridge exam. The test for perpendicularity is if you multiply your slopes and you get -1. So means if I have M1, that is the same as -1 over M2. Okay, the negative reciprocal is your perpendicular line. Negative reciprocal. So you flip it and make it negative. So if my slope is 1/2, my parallel line is -2. Or sorry, not my parallel line. My perpendicular slope is -2. You have two forms of linear equations. Again, these are not given to you on your formula sheet. So make sure you remember these. And if you only remember one of them, they are derivatives of each. They not derivatives. They are derived from each other. So you can generally get the job done with either one. It just might be quicker to do one or the other. So we have our good old y equals mx plus c. We're used to seeing it y equals mx plus b, where m is our gradient or our slope, and c is our y-intercept. It's useful when graphing because you just find the y-intercept, go up your slope, up 2 over 1, and then connect those to your 2 points. Point slope form. Okay. Those are your point, and again, m is your slope or your gradient. This one is useful because if we have a point and then we can, and a slope, we can go up, over, draw a point, and go lines through it. So here's a particular practice problem I'm going to work through with you. Follow along. If you have any questions, make sure you bring them to class. So we have point P, which is K and 2K, is equidistant from A and B. Find the value of K. So think about what this looks like. So if we have A and we have B, and we have some point P, this are congruent. They're the same distance apart. So delta x squared plus delta y squared square root equals d. So I'm going to try this method and we'll see if we get in too deep. And if we do, then we will find another way. So my change in x is going to be 8 minus k squared plus 11 minus 2k squared square root. And that is the same distance as the square root of 1 minus k squared plus 12 minus 2k squared. Okay. So let's work this out. So if I square both sides, that gets rid of some stuff. So I end up with 8 minus k squared plus 11 minus. So I'm going to do a couple steps here, actually. So it's going to be. So I'm going to need lots of room for this. 64 minus 16k plus k squared plus 121 minus 44k plus 4k squared. It's all going to be equal to 1 minus 2k plus k squared. Plus the other one, I run out of room. So I'll get that on the next line. Let's simplify this. So those are like terms. Those are like terms. And those are like terms. So 185 minus 60k plus 5k squared. And that's going to be equal to, squeeze over here, this is going to be 144, 48k, and 4k squared. So this is going to be 145 minus 50k plus 5k squared. Let's do some looking. 5k cancels out on both sides. If I add 60k and subtract 145, I get 10k equal to 40. So k is equal to 4. There you go. So in this one, we looked at the equations of a straight line using point slope and slope intercept form. We looked at the key features of both of those forms so you can interpret. And then we looked at parallel lines and perpendicular lines and their formulas, along with the distance formula and the midpoint formula and how to prove if something is parallel or perpendicular. Homework 3 is these 4 problems, 2, 5, 9, and 12 on page 92. Make sure you're working on that. This unit is going to be very quick.